Hello. Okay, so today we are going to talk about next in sequence. Basically, it is an interview question. Many interview ask these questions: how this function behaves, and also it is used in some of the use cases. Uh, it may not be at a large extent, but some of the use cases can be solved by next-in sequence. So what next-in sequence is? So it gives the successive number of the records, okay, within a process. So within a graph or a plan, what is the process? So a component is called a process. So whatever is defined in a component, see, that is a unit of processing. That is called a process. So if it is a sort component, then followed by reformat component, and followed by roll-up component. Then these are three processes: sort process, reformat process, and roll-up process. Okay? So if we this is for a serial process, single process. Okay, a component. If it is a multi-way and way processing, then there are n sort processes, there are n reformat process, and there are n roll-up process. Each partition will be a process of that component kind. So the kind of process is going to be different. So there will be n plus n plus n 3n processes in total. Or in serial process, there are only three processes. So within a single process, this next in sequence is going to give the next successive number for a particular record. So if it is processing first record and we are calling the next in sequence, this next in sequence is going to give number one. Okay, and for the second record, because it's going to be called at second time, then it will give the number second. So we are going to see this in a some example just after few minutes. Okay, so this is the about definition of next in sequence. Okay, so let's take an example. Okay, so we have an input like so we have a component or a you could look at a process, or we are processing it as a serially, or we have an input like field. We have only one field, and we have a data record like 1A, 2A, 3A, 4A, and somehow we are going to assign. We are going to process through the reformat, and our output is required is like we need to assign the sequence number to that, and we have some reformat configuration. So this is a two-way reformat. There are two ports, two output ports. Okay, count is two. There is a selection criteria in the reformat, and there is an output index is defined in the reformat, and there are two transformation differently, uh, you know, coded. So this is the all configuration of the reformat processing. So let's try to assign the what sequence number is going to come, right? Sequence in the sense of I should say here, right? Output sequence number. I would you know, code like this. So what we need to do, we need to somehow calculate what sequence number is going to get. So this is output one, let's say. Similarly, there will be output two as well. Okay. Let's see how. So I for this example, every record is going to come in both the ports. Okay. Output index I have coded like whatever is the condition vector 01, also vector 01. This is for an example. In whichever way you want, you can do it. You can do it like this as well. So that is going to happen. So for instance, I have taken like this. So all the records are going to go into the both the ports. Now let's try to solve this sequence number. For first record, let's say this one A is going to process. So first it is going to, if we know the runtime behavior of any particular component, in this case we have a reformat, so we know the runtime behavior. So what is the hit? First it is going to be selection of the data. So next in sequence is less than or equal to 900. So this is satisfying. So next in sequence for first record, first time it is 1. So this is going to return 1. 1 is less than 900. Yes, correct. Now it is going to switch to the output indexes. So it is going to decide, which ports the reformat has to route the record. Okay. So now again the next in sequence is going to be called. So this time this function is going to return 2. So 2 modulus 2 is equal to 0. Yeah, this condition is getting satisfied. Then my record 1A is going to go into the vector 0 and 1. It means of both the ports. So this record is going to go to the both the ports. Now it has been decided where the record is going to go. So it will switch to the respective transform. So the respective transform is both the transform. So one by one, let's see. So now for transform port number 1, sequence number, next in sequence again it is getting called. So first time, second time here, third time here. So this port number 1 sequence number is going to assign as 3. So let's say it's port 1 number 1. So this number is going to 3. Now again it is again going to go to the second port because we are routing record to the both the places, right? So it will again next in sequence because it's a similar same process. So the next successive number is going to come. So for output 2, let's say here, okay, output 2, this number is going to be 4. Okay, so finished, we have finished the record number 1 processing. So we have number 4 currently. Now second record, second 2A is going to be processed. So what is going to happen? First it is going to hit the selection. So 4, now it is going to, next in sequence is going to return 5. 5 is less than 900, yes, correct. It is going to go into the output indexes. So this is getting 6. Now 6 modulus 2 is going to be 0. Then it is again going to be routed into vector 0 and 1. So my sequence number for 2A is going to go to the, because 6 and then 7. So it becomes 7 over here. And similarly 8 over here. Okay. And then, it will go on like this for all the records. Okay. So that you can, try and do. So simple way. So next in sequence is going to be incremented. It will depend upon how many times it is going to be called in particular process and what is the sequence of the execution of the process, the small functions within the process. So depending upon that, we will achieve the output. Okay? So this is, so what we need to, to know how the next in sequence is going to behave in a particular component. What we should know? We should know the runtime behavior of the component. Second, we should know the how many ways parallel the component is executing. So this we have calculated for serial processing. If it is a parallel processing, so the runtime behavior or the sequence number calculation is going to be different. Okay, so this also I am going to see how it may differ. Okay, so now with the partition flow. Okay, so I need to zoom in. Okay, so now because we have different partitions, okay, within a single component, let's say 4-way partitions. If my reformat is getting executed in 4-way, so to calculate the exact number, right? To calculate the exact sequential number, we have a formula. So this formula will depend upon the next in sequence code, the number of partitions, total number of partitions in the sense of how many ways parallel this reformat is getting executed or any particular component is getting executed minus number of partitions minus 1 plus this partition in the sense of which partition, like 0th partition or n minus 1th partition. Okay, so for partition number 0, you know, for partition number 0, this value will become 1. If it is a 4-way, 1 into 4, right, minus number of partitions, minus 1 means 4 minus 1, 3, plus this partition in the sense of 0. So what is the number? 0. This becomes 0, right? Oh, sorry, this is 3, right? 3. So 3. Because number of partitions 4 minus 1, 3. So 4 minus 3 plus 0 becomes 1. So for first record, this number is going to be come as 1. Right? For second record, within second partition, the next in sequence, let's say it becomes 2. And number of partitions is 4 minus number of partitions 3 minus 1 plus 1. If my second record is in second partition, then what is the assignment? Next in sequence is going to be 2, number of partitions 4 minus 3 plus 2, which are 8 minus 3, 5 plus 1, 6. Right? But what about 2 to 5? 2 to 5 is, if you calculate, partition 0. Okay? So 1 to 5 record is going to go into the partition number, first partition. So this is for calculation of partition number 1. Okay? Or partition 1. This calculation is for partition 2. Okay. So if we calculate the second record of partition 1, then what is going to calculated? Next in sequence, let's 2, right? And plus number of partition 4 minus 3 plus 0, right? This is again 5. If we calculate like this, there will be no overlap of the record. Sorry, 5. There won't be any overlap of the numbers. Okay, so if you want to generate the sequential number for a multi-way processing, then you can use this formula. But we need to be careful. If our configuration of the component is heavy in the sense of we are going to talk about. So the next in sequence define and select an outbound action transform and will be shared. So what is going to happen in this parallel processing? So then what is going to happen with the next in sequence if we don't define this function? Okay, if we are just calling next in sequence, so what is going to happen? It is going to be shared. So if I talk about the reformat and it is four-way processing, then the select, there will be only one select and there will be only one output indexes and there will be a number of there will be multiple transform, right, for a respective partition. For because respective partitions are going to be different, right? So partition number 0 to partition number n, but the select and output index are going to be shared among all the partitions because there will be one. Right? So the next sequence number is getting impacted by the calls of the select, output index, and the partition. Okay. So if I call the next sequence in select, then let's say it went to the output indexes. Okay, then that number is for first record. So if this record belongs to partition number 0, so the processing will be depending upon the next sequence call. If it is here, and then particular partition, right? Okay, but it will not interfere between partitions, so it won't know, So the number which is generated in partition 0 can be generated in partition 1 as well. So this call, the next in sequence call in select, next in sequence in call in output index will impact all the partitions, but within this partition, this next in sequence is going to be separate, right? Because we have a separate process, right? So that you can try and test upon. Okay, this is for exercise. What is the exercise? Uh, the exercise is you take the four-way multiway, then define the select, and call the election sequence over here, then define the output indexes and output indexes, okay, and then in reformat also you try to call the output index and then there is an output. Okay? Now, so that you can try and test it. Okay. Discuss join component as well. So I was talking about depending upon the complexity of the configuration. So we have join component. So there more than two inputs, two or more inputs will be happening in the join processing, right? So in join process, we will have selection, different selection, dedupe, and all those parameters, right? So the selection and dedupe. So dedupe happens whenever duplicate records are there, then they are going to be dropped, right? So in if you are calling the next in sequence in respective selection, so those next in sequence will uh, in the respective partition they are going to be treated upon, right? So the first next in sequence will be depend upon the arrival of the record from the port 0, okay, and that next in sequence will be used for port 1 as well because it is calling in the same process and it is calling second time. So that calculation is going to be impacted. So we have to be very careful about action sequence uses whenever we are going to use join. So in this processing, it's not meaningful to use, but technically, if you try to use it, it's going to give entirely different records. So that also you can try and test it. Okay. We join roll up and multi-input port components, right? So we don't have to use it basically because the uses are limited. So that uses how we use the action sequence. But so if we theoretically, if we want to try to see the processing of action sequence, so you can try with the some complex components, how it happens in roll-up component, how it is happening in scan component, right? And what happens, if it is a multi-input ports like we have joined, right? So if the data process is in memory or sort, that is also you know uh, we need to take. For example, so if there is an action sequence, in the select parameter of join, right? So if the processing is in memory, right? So what is happening is going to be loaded everything. Then the selection is going to happen, and then so what is going to happen is let's say in the roll up. So in memory roll up, right? So when the finalized function is getting called, so that it's entirely depend upon the runtime behavior, right? So after processing of all the record, then only finalize is going to be called, right? In the case of in-memory sort, in the roll-up and scan, right? So if we are calling next in sequence in finalize, then the sequence is going to be entirely different. Then if we are processing it as a sorted data, okay? Because in sorted data, after grouping, the output happens, right? The finalize is getting called. Similarly, in the scan also, if the data is sorted, then after the first group process, then I mean finalize is getting called. I mean getting called for each and every, but after grouping first, that group is getting finished. Okay, and but I think it will impact on the it won't impact in the scan, but in the case of roll up, right? So roll up will keep on holding the record until the last record is not going to come in the in-memory sorting. In the case of scan as well, right? If it's not, it will wait for the last record. Okay. Uh, so for the roll up and scan, this processing is going to be entirely different. So it will depend on a different factor, right? If it is in the case of join, roll up, and scan, if it is in memory or sorted, if the data processing is in parallel or in sequence, if data has a duplicate, how many times a join, roll up, scan gets called. So yeah. So in the case of if we don't find any join for a particular record in input 0 and input 1, then or basically the respective roll up is or the respective join reformat is not getting called. In that case, it's kind of discarded record. So it's not going, the next in sequence will depend upon that also, because this time join it did not call, so that next in sequence is not going to be impacted for further for the next record. So entirely, all and all, we should know the runtime behavior, the sequence of execution, the configuration, and the expected, the flow of the data within the component, and how many ways parallel this component is going to be, processed. So, so, all in all, I mean, after discussing this much, so what we have concluded is we mostly ignore to use in parallel processing and all this next in sequence. We try to utilize in only serial processing, and if we have to use then in partition way, then we will try to use this formula, basically this formula. Okay, and that too in the simple processing. We don't have many multiple sequential call within a particular component. Then also we can try to utilize that formula in multi-way processing. So what are the use cases to reverse the order of the data? So if we have 1,000 records and someone says that I want to reverse the data of the record. So what I'm going to do is I need to create one field and assign the next in sequence number. Okay, so 1 to 1,000, and then I'm going to sorting on descending sort. Okay, I will apply the sort component descend. Okay, so in that way I can reverse the order of the data. So this is one use case to assign surrogate keys. Sometimes we do assign the surrogate keys, and that surrogate keys, the final surrogate is we are going to store in some file or some database. And next time, whenever this processing happens, we increment upon that number for the next records, right? So this is one way of assigning surrogate keys while processing, and also we do the ranking of the data within the data set. So let's say I have 1,000 records and we want to rank this. So rank in the sense of the number of the sequence number we want to assign. So whether we are assigned within a group or within partition or globally. So it will depend. So globally we can do easily. If it is a serial processing, we just assign the next in sequence. If we are processing within groups, in the sense of we can do the scanning, okay, within group, and within partition we are going to do, then we can just simply will call the next in sequence. We are not going to use the partition, that formula, because within partition we are going to assign the number. So within single partition, what is the what is the placement of the record? So this is all about next in sequence. So, okay. So yeah, I with that I'll stop it. Okay. Thank you so much.